Hi guys, back with me again, Aji Kurniawan Yusuf. In this video, we're gonna learn together about linear regression. Before we learn about linear regression, I want to explain to you first about what is independent variable, what is dependent variable. Independent variable is variable that affects. In other words, independent variable is variable that can stand alone or may be changed. While dependent variable, it is the variable that is affected. Or in other words, I can say that dependent variable depends on the value of the independent variable. For example, promotional budget and also sales. Which one is correct? Does promotional budget affect sales? Or does sales affect promotional budget? Promotional budget affect sales is more appropriate. In this case, promotional budget is what affects, while sales is what is affected. Therefore, promotional budget is independent variable, while sales is dependent variable. This is the example of conceptual framework. The left side is the independent variable, while in the right side is the dependent variable. In this case, there are two independent variables. They are customer satisfaction and customer trust, while the dependent variable is repurchase intention. Customer satisfaction and customer trust are the variables that affect, while repurchase intention is the variable that is affected. Now, let's go to linear regression. Linear means straight line or power of 1. There will be quadratic regression, there will be cube regression, but we will not cover in this video. We only cover about linear regression. So the purpose of linear regression is to find the best fit line that describes the relationship between two variables. The two variables here are independent variable and dependent variable. Independent variable is denoted by x. You need to put the x in the x-axis. While for dependent variable is denoted with y. You have to put it in the y-axis. As I mentioned previously, since it is the power of 1, of course the line will be straight line. The line equation is the regression equation. The general line equation is y equals to a plus bx. The a here is the constant, while the b is the coefficient of the x or the slope of the line. The regression equation is found using least square principles. Least square principle is determining the regression equation by minimizing the sum of square of the vertical distance between the actual y value and also the predicted y value. Or in other words, I can say that least square principle is trying to minimize the sum of square of the error. The next question is that how if there are more than one independent variables? Don't worry, if there are more than one independent variable, we call it as multiple linear regression. The concept of the regression equation will be the same, but there are several modifications. It will be like this: y equals to alpha, or we can write as b0 plus b1 x1 plus b2 x2 plus b3 x3 and so on plus error. b0 or alpha here is the constant. The constant is the y-intercept. x1, x2, x3 are the independent variables, while b1, b2, b3 and so on is the coefficient of the independent variable or the slope, while the e is the error term. This is how you can interpret the linear regression equation. As I mentioned previously, b0 or alpha is the intercept or the constant. It means if all x are 0, the value of the y will be equal to alpha or b0. While b or beta here is the coefficient or the slope or the gradient. This is how you can interpret. If variable x1 increases by 1 unit and the other variable stays the same, the value of y will increase by beta 1 or b1 units. If the variable x2 increases for 1 unit and the other variables stay the same, the value of y will increase by beta 2 units. This is the information for you guys. You can interpret the beta 1, beta 2, beta 3 if the data is interval or ratio. However, if the data is ordinal or it is in the form of Likert scale, you cannot interpret the result since it doesn't make sense. This is the example. Let's try to interpret. The effect of the leverage x1 and the operating cash flow x2 toward profitability y in million is as follows. Y equals to 2.4 minus 0.31 x1 plus 2.6 x2. Interpret the result. These data about leverage, operating cash flow, and also profitability are interval or ratio. Therefore, we can interpret it. So let's interpret 2.4. If there is no leverage and there is no operating cash flow, the profitability will be 2.4 million, all else being equal. All else being equals means the other factor stays the same. Now let's interpret minus 0.31. A leverage increase for 1 million will reduce profitability 0.31 million, all else being equal. Now 2.6. An operating cash flow increase for 1 million will increase profitability for 2.6 million, all else being equal. The other example. The effect of the brand awareness x1 and brand trust x2 toward brand loyalty, the y is as follows. Y equals to 3.1 plus 0.64 x1 plus 2.15 x2. Interpret the result. We know that the brand awareness, brand trust, and also brand loyalty is the latent variable. We have to distribute the questionnaire to get the value. And the value is actually in the form of the Likert scale. As I mentioned previously, it doesn't make sense for us to interpret the result if it is in the form of ordinal scale or Likert scale. Therefore, we cannot interpret the result. Now, if the linear regression describes the relationship between independent and dependent variables, what is the difference between linear regression and also correlation? Correlation tells us the strength and also the direction of the association. After testing the correlation, we will know the strength of the association. It is strong, moderate, or weak, positive, or negative, without implying causation from one variable to other variable. We don't know which variable affects the other variable. We just know the association between these two. While linear regression tells us the relationship between independent variables and dependent variables, how the independent variables affect the dependent variables in the form of the regression equation, so we can predict the value of dependent variable based on the value of independent variables. So the correlation does not imply the causation, while linear regression implies causation, independent variables to the dependent variables, and we will find the regression equation so we can predict the value of dependent variables based on the value of independent variable. This is the important thing as well. Later on, when you conduct regression analysis, the result can be significant and not significant, or I can say insignificant. Significant effect means strong enough to believe that the relationship is real, not due to by chance. If the effect is significant, we can determine whether the effect is positive or negative. While not significant effect means it doesn't have meaningful impact. No need to state the direction since there is no impact. So we cannot say that the relationship is not significant and negative. We cannot say as well the relationship is not significant and positive. If it is not significant, it means that it doesn't have any effect. No need to state the direction. Before we run the linear regression, this is the important for you guys. There are several steps you need to conduct before you conduct linear regression. The first one is validity and reliability test. As I mentioned previously in the previous video, you can skip this part if your data is secondary data that comes from the valid and reliable sources. However, if your data is the primary data, you have to conduct validity and reliability tests. The second one, if you want to conduct linear regression tests in SPSS, you have to conduct classical assumption tests and make sure that all the classical assumption prerequisites is fulfilled. After that, you can conduct linear regression tests. The important result that you need to provide after conducting linear regression tests is R-square, F-test, and also T-test result. And the last part, if you deal with the mediating and moderating variable, you need to conduct mediating and moderating tests. Now, let's try to run linear regression in SPSS. Alright, so I have several data from several variables here. There are 4 variables, x1, x2, x3, and also y1. So we know that the independent variables are x1, x2, and x3, while for the dependent variable is y1. If we see from the data, we know that the variable is the latent variable, so they use several indicators. In this case, x1 has 4 indicators, x2 has 4 indicators, x3 has 3 indicators, and y1 has 4 indicators. For this data, we have conducted validity and reliability tests, and these are the valid and reliable variables and indicators. And we have also conducted classical assumption tests, and it has met the requirement of the classical assumption. So in this video, we just cover how to run the linear regression. Basically, linear regression should be conducted for the scale measurement. It consists of interval or ratio. It could not be used for the ordinal variable. Therefore, the ordinal variable actually should be converted into interval or ratio variable using we call as MSI, method of successive interval. However, several previous research tried to convert the ordinal variable into interval variable using MSI, but the output is not far different. Therefore, it is concluded that MSI is not effective yet. So it's okay for you to just use the ordinal variable in this linear regression. The most important thing is that you have to find the average of each variable indicators. So for x1, find the average using average formula. For x2, find the average as well. For x3, find the average. And for y1, find the average. Now you drop down like this. What you need is only the average. So you can copy the x1 average into SPSS, and then x2 average, x3, and y1. We give the name first. This is the x1 average, x2 average, x3 average, and also y1 average. In the label, we can put this is x1, x2, x3, and y1. Just put the measurement scale here. Alright. Now, let's try to conduct regression analysis. This is the way. Analyze regression linear. So you can move the independent variable and also dependent variable. The independent here, x1, x2, and x3, move it to the right, while y1 is the dependent. If you know the name of the variable, you can put in the label as well. For example, the x1 is brand satisfaction, the x2 is brand trust, while y1 is brand loyalty. You can put it as well if you know the name of the variable. And then OK. Alright, there will be 4 tables here. Variables enter or remove, model summary, ANOVA, and also coefficient. Let's see first the model summary. In the model summary, there are R. R here is the correlation coefficient. As you have learned in the previous video, correlation coefficient will determine the strength and also the direction of the association. Here, the R is 0.78. It means the independent variable has the positive association with the dependent variables. And the relationship is moderate because it is close to 0.5. R squared. What is R squared? It is just the correlation of the coefficient square. 0.609 comes from 0.78 square. But how we can interpret the r square? You know, right? The y1 actually can be affected by a lot of variables, not only by x1, x2, or x3. There are still other factors that can affect y1. For example, y1 is brand loyalty. There are a lot of factors in this word that can affect brand loyalty. Not only 3 factors, 3 independent variables. But there are the other variables that can affect the brand loyalty. R squared here tells us about how many percent of the dependent variable can be explained by the independent variable. So x1, x2, and x3 can explain the dependent variable in the amount of r squared. The higher number of independent variables inputted in the regression equation, the higher r squared will be. The r squared will range from 0 until 1. Higher value of r squared indicate the better model. There is no universal standard of the value of the good r squared, but there are several opinions. For the primary data, if you distribute the questionnaire using the Likert scale, good r squared will be more than 0.5. But if you have secondary data, good r squared is when your r squared is more than 0.2. But again, actually there is no universal standard of the good r squared. In this case, the r squared is 0.609. It indicates good r squared. It means the model has been good. It means that the independent variables can explain 60.9% of the dependent variable. The next one is adjusted r squared. As I mentioned previously, if you add the number of independent variables, the r squared will also increase. However, adjusted r squared only considers the variables that affect the dependent variables. The higher number of independent variables does not guarantee that the adjusted r squared will be higher as well, since it only considers the variable that affects dependent variable. Standard error of the estimate states the average deviation of the error of the regression model. So the lower it is, the better the model. The second table here is ANOVA table. From this table, we will find the result of the f-test. F-test is used to know whether the independent variables together can affect dependent variable or not. So the combination x1, x2, x3 together can affect the dependent variable or not. The f-test is also said as goodness of fit test. We can see from the sig part. Sig part here is the p-value. If it is less than the significance level, the common significance level used is 0.05. So if the sig or the p-value is less than 0.05, we can conclude that the independent variables, in this case x1, x2, x3, together can affect dependent variable, in this case y1. Or in other words, we can also say that the model is fit. The model is good to analyze. How if it is more than significance level? It means your model is not good. Therefore, you have to change the independent variables, or you need to add independent variables, or you need to redistribute your questionnaire. In this case, the p-value is less than 0.001. It means the model is good. Or I can say that the independent variables together can affect dependent variables. The last part is the coefficient table. We will find the result of t-test in the coefficient table. T-test is used to find the partial effect of each independent variable. So we will find the effect of x1, x2, x3 individually, not together. You can see here, the p here is unstandardized coefficient. We can create the regression equation based on the unstandardized coefficient here. The regression equation will be y equals to 0.268 plus 0.451x1 plus 0.635x2 minus 0.171x3. This is the regression equation. Besides knowing the regression equation, we want to know whether each x1, x2, and x3 affect dependent variable or not. How to know it? You can see it from the sig. Actually, you can use the t statistic as well. This is the t statistic or the t calculation. To know, you need to compare the t calculation or t statistic with the t table, but it is complicated. So it is easier for you to find from the sig or the p value. If the p value is less than significance level, for significance level 0.05, I can say if the p value is less than 0.05, the independent variable affects dependent variable. One more time, if the p value is less than significance level, or in this case 0.05, the independent variable affects the dependent variable. If it is larger, it means the independent variable does not affect dependent variable. In this case, the x1 p-value is 0.001. It is less than 0.05. We can conclude that x1 affects y1 or the dependent variable. How is the effect? The effect is positive since the coefficient of the b is positive. x2, the p-value is less than 0.001. So we can conclude as well that x2 affects y1. And the effect is positive as well since the coefficient here is positive. While x3, the p-value is 0.186. It is higher than 0.05. Therefore, x3 does not affect y1. If it does not affect, you don't need to find the direction. Even though it is negative, if it doesn't affect, there is no effect. So in this case, x1 and x2 affects y1 positively, while x3 doesn't have any effect. Is it clear, right? Now let's try for secondary data. I have secondary data here, debt, length of intellectual capital, and also length of profitability. The independent variable is the debt and length intellectual capital. The dependent variable is length profitability. I want to conduct regression test. Again, since it is secondary data, I do not conduct validity and reliability tests, and I have conducted classical assumption tests. Therefore, I can conduct regression analysis. So, the step is the same, analyze, regression, and linear. In this case, I put debt and length IC into independent variables, and learn profitability as dependent variables, then okay. In this case, we can find the R is 0.738, the R squared is 0.545. For the secondary data, it is considered as good because it is more than 0.2, especially it is more than 0.5, right? For the F-test, we can see the sig here is less than 0.001. It means both independent variables together can affect the dependent variables. So debt and intellectual capital together can affect the profitability. From the goodness of fit side, we can see that the model has been good or fit to run. The last one is the coefficient one. It is for the t-test. We want to know the partial effect for each independent variable to dependent variable. We can see here the sig for debt is less than 0.001. It means debt affects profitability. And the coefficient here is negative, so we can know that debt affects profitability negatively. While for the intellectual capital, the p-value is less than 0.001, it is less than 0.05 as well, so we can conclude that the intellectual capital affects profitability, and the effect is positive since the coefficient here is positive. If we want to create the regression equation, it will be y equals to 1.566 minus 0.014 debt plus 0.029 intellectual capital. You can add with error as well.